Hello, hello. Let's look at some examples of solving equations. We're going to stick with linear equations. I'm going to start really simple here, but I might put some more complicated numbers into it. Start with basically the basic addition principle. We'll just do an example of that first. Yeah, really basic. So we got -8 plus r equals 17. -8, add 8 to both sides. Basically, you just add the opposite of whatever this is. If you've got things added together, to get that variable by itself, you just add the 8 to both sides, add the opposite of -8, which is +8, right? So what does that do? -8 plus 8 is 0, so that's just 0. 0 plus r equals 18 plus 17, 25. Okay, let me do another one. I'll just make this one up. -5/8 plus y equals 1/6. What do you think? Well, we've got y is fine. There's just a 1 on that. Anytime you see a variable, you might as well you can think of it as just having a 1 next to it, and so it's going to already be by itself once we add 5/8 to both sides. We look at this -5/8. We're going to add 5/8 to both sides. 5/8, add 5/8 on this side, and so we get 0. -5/8 plus 5/8 is 0. Y equals, I'm just going to write it out, 1/6 plus 5/8. Now we're not done yet. We have to figure out what that is equal to. Well, I'm purposely using fractions here because it's not a bad idea to practice your fraction work and not rely on a calculator here. So let's practice this. Well, we need a common denominator to deal with add a sixth to eighths. Whenever you're adding fractions, you need a common denominator. That means that these denominators are different. We need the same denominator. Well, what's our common denominator? Well, it's the least common multiple of 6 and 8. It's the multiple of 6 and 8, and it's the smallest such multiple, the smallest number that 6 and 8 both go into. Well, that's 24. Well, 6 times 4 is 24. So if I multiply this by 4/4, I get 4 over 24. So y equals 4/24 plus 5/8. 8 times 3 is 24, and that means 5 times 3 on top. I'm multiplying by I'm just unreducing these fractions. 1/6 unreduces in some sense to 4/24. I'm just rewriting, unsimplifying those fractions so that they have the right denominator, the common denominator. Now, once we have a common denominator, we can add across the top. So we got 4 of those 24ths and 15 of those 24ths. Well, that's 19 24ths, and that doesn't reduce any further, so that's our answer for that one. Okay, well, now let's look at multiplication principle. 3/5 s equals 9/8. Well, whenever I have a number times a variable, I'm going to need to divide by that number that's next to the variable in order to get the variable by itself. In order to make the number next to the variable 1, I have to divide by, well, in this case, 3/5. Well, dividing by 3/5, any fraction, dividing by a fraction is the same as multiplying by its reciprocal, 5/3. I have to do that to both sides, so I get 5/3 on this side as well. Now you'll see the reason why we do this. 5/3 times 3/5. Those 3's cancel, those 5's cancel because we're multiplying. This only happens when we're multiplying. Again, you cancel things. But that just becomes 1. This whole thing is 1. 1 times s is just s. 9/8 times 5/3. Well, this 9 and this 3, this 9 and this 3, there's some canceling there too, because 9 divided by 3, 9/3 is 3/1. So this becomes 3 and this becomes a 1. And then we just multiply across the top and the bottom. When we're multiplying fractions, that's how you do it. That's when you multiply across the top and bottom. And you can only cancel when you are multiplying these things. Cannot be canceling if you're adding fractions together. So that's just something that I see a lot, an error I see a lot, and I always try to mention it. Anyway, 3 times 5 is 15, and 8 times 1 here is 8. S is equal to 15/8. Now, it's not a bad idea to check these as you're doing them. Check them with your calculator or something. Plug these numbers, whatever you get, plug it in for S in the original equation, and see if you get a true statement. So you get the same number on both sides of the equal sign. You can use a calculator for that. That's fine. Let's combine these two. Let's combine these two methods. So we've done the principle is still doing the same thing to both sides, but let's combine the methods where we have to do an addition principle idea and then a multiplication principle. Let's take 2/3 x minus 1/2 equals 1/4. Okay, I just made this up, so it won't come out terribly nicely. It might not be too bad, but you can't be afraid of that. So I'm using fractions because we want to practice that as much as we can. So when you have something like this, you have something times x plus something else, and by the way, this is plus a negative 1/2. It's the same as if I was writing that. That's the same thing as subtracting, and sometimes I often just start to see it a minus as adding a negative. So we got 2/3 x minus 1/2 equals 1/4. Well, first I'm going to get this 1/2 moved over to the other side. Add 1/2 to both sides. So the idea is get the term with the variable by itself first, then get rid of whatever number happens to be in front of it through the multiplication. So you do addition principle, then multiplication. So addition principle, then multiplication principle. So I'm adding 1/2 here. That leaves me with 2/3 x on this side. On this side, it's 1/4 plus 1/2. Well, 1/2 is equal to 2/4. So it's 1/4 plus 2/4. Well, that's 3/4, as you'd expect. A quarter plus a half. A quarter plus 2/4 is 3/4. So now I've got 2/3 x equals 3/4. Well, now I can just multiply both sides by the reciprocal of 2/3, which is 3/2. That's what I need to multiply in order to make this whole thing a 1 times x. And if I do the same thing, multiply by 3/2 on this side too, then I get x equals 3 times 3 over 4 times 2, 9/8. And that should be it. Let's look at something a little more complicated. Something where we might have to do some simplification on either side first. I think I'm going to start, let's do a decimal one just for fun. 0.9y minus 0.7y equals 4.2. Well, you'll notice that we've got a number times y minus another number times y. I've got 9/10 of a y and 7/10 of a y. Take 9/10 minus 7/10, so I can subtract those two numbers, those two coefficients, and combine these like terms. 0.9 minus 0.7, that's 0.2y equals 4.2. And now I can divide by 0.2. And if I divide by 0.2, that's 4.2 divided by 2/10. And that's the same as 4.2 times 5. 4.2 times 5 is the same as 4.2 times 10 divided by 2. So it's 42 divided by 2, which is 21. You don't have to do it this way. You can just whip out the calculator for this, but it's not a bad idea to practice your mental math. So y is 21. let's look at this one. (8x minus 15 equals 7x plus 12, say. Well, something like this, you can see, oh, you got x's on both sides. If you see your variable on both sides, then that means you need to get those together. Just like I would like to add 15 to both sides to get the numbers together. Well, I'd like to get my x's together on one side, and that's usually good practice. So in order to do that, you could subtract 8x from both sides, or I could subtract 7x from both sides. Either way is fine. I like subtracting 7x because then I know that I'm going to get a nice positive number there. 8x minus 7x is 1x, right? 1x, or just x. And so I get x minus 15 equals 12. Now I can add 15 to both sides. And I get x equals 15 plus 12, which is 27. That's it. Let me throw a little curveball at you. Negative 3a plus 4 equals 5 minus 3a. Well, let's look what happens here. I'd like to get these a's together, right? Okay, well, let's add 3a to both sides. Well, this is already looking kind of odd. Negative 3a plus 3a, well, that's 0a. 0a's, well, that's 0 times a is 0, so that's 0 plus 4 equals 5. If I were to subtract 4 from both sides now, I get 0 equals 1. Well, if this ever happens, if you ever get something like 0 equals 1 or 1 equals 2 or 8 equals 5, anytime you get an obviously false statement that there's no variables to be seen, this is always false. That means there is no number you can plug in for a that makes this true. It's always false. Because I did everything legally from this equation down to here, did everything legally, and the resulting equivalence equation is false always, which means there's no solution. There's no number for a that will make it true. That's no solution. Now it's possible to have a similar situation happen where, say, I had negative 3a plus 4 equals 4 minus 3a, say. Well, in this case, if I add 3a to this side and subtract 4 from both sides, then I get negative 3a plus 3a, that's 0a, which is 0. 4 minus 4 is 0. 4 minus 4 is 0. This is 0. So I get 0 equals 0, and that's always true. So what that tells us is that no matter what a is, there's no a here. It's always true. So that tells us no matter what a is, this is always true. So in this case, the solutions are all real numbers are the solutions. All the real numbers. The whole number line is a solution, are our solutions. Let's look at this. 6. So first, there's things you could do, to both sides immediately, but I'd probably recommend multiplying through on both sides first. Use the distributive law to multiply through. Now this is, sometimes you could maybe divide both sides. I could divide both sides by 6 from the get-go, but then I'd have a weird fraction over here. I'd have 10 over 6. I don't want to deal with fractions if I don't have to. And I see that there's x's on both sides. We can't bring those x's together until we multiply through. on either side. So let's multiply the 6 through this. So 6 times x is 6x. 6 times negative 5. I'm thinking this is adding a negative 5. That helps me keep track of negatives and not lose any negatives anywhere. So 6 times negative 5 is, and again I'm going to write it as a minus, but I'm still thinking plus a negative. That's negative 30. On this side, we'll multiply through with a 10. 10x, 10 times x, plus 10 times 3, which is 30. Now we can get x on both sides. Now, here's kind of what I do. I'd rather not have a negative in front of the x if I can help it. It doesn't really matter. I can divide by a negative number. I know how to divide by a negative number, but it sometimes makes it a little bit easier if I subtract x from both sides, or sorry, subtract 6x from both sides, then this will leave me with a 4x. On this side, 4x plus 30 equals negative 30. Alright? Well, I like that. It doesn't matter. X on this side is fine. X on the right, the x's on the right is fine. It just means that I got to get the other numbers on the left side. That means I have to subtract 30 here. That's negative 60 equals 4x. Now I can divide by 4, or I'll just, for the heck of it, write it like this, multiplying by 1/4. Notice I'm putting parentheses around the negative 60 just so I don't think that that's, for some reason, a minus. Like I'm taking 1/4 minus 60. It's a multiplication. I don't want to mix myself up. So 4x times 1/4, that just leaves me with 1 times x. So that's just x on this side. And 1/4 times 60. Sorry, negative 60. That's negative 60/4, which is negative 30 over 2, or negative 15. You could write those steps if you like. Now, oftentimes, even though I have x on this side, I'll usually rewrite it if I'm writing my answer. It just so it reads better. If I were to read this left or right, it says x is equal to negative 15. Doesn't really matter, but this is kind of the convention. It's good to put the variable first if you can. So that's that. I think I'll do one more. This is kind of dense with fractions. That's okay. Let's just walk through it. Well, all my x's are at least on one side. I don't have x's on the other side of the equal sign, so that's good. I will probably want to multiply through with 3/4 at some point. I might as well do that right now. Multiply 3/4 times 3x, and then we'll multiply it by negative 1/2. So 3/4 times 3x is going to be 9/4 x, right? Remember, this is 3 over 1, so 3/4 times 3 over 1 is 9 over 4. Multiply across the top and the bottom. 9 over 4 x minus 3/4 times 1/2. 3/4 times 1/2, that's 3 times 1, which is 3 on the top, 4 times 2 on the bottom, which is 8. And then out here we still have this plus 2/3 equals 1/3. Okay, now there's a couple things you can do, couple ways you can do this. You can get a common denominator and add these guys together, and then get that on the right. Move that over to the right side by either adding or subtracting the same thing on both sides, and that's fine. If you kind of don't really want to deal with fractions as much, we can do something slightly different. We can take it's basically ends up being the same, but we just don't have to write nearly as much. We can do what's called clearing the fractions, clearing the denominators out. I do that by multiplying both sides by basically the LCD, the least common denominator of all of these guys, what all of these denominators go into. It has to be a multiple of 8, and it has to be a multiple of 3. So 24. If we multiply both sides by 24, check this out. 24, we have to distribute still to each one of these terms. Multiplication distributes over addition, so each one of these three terms has to be multiplied by 24. If we take 24 times this, the way I usually do it is just take 24 divided by this 4 and then multiply that answer by 9. So 24 divided by 4 is 6. 6 times 9 is 54. X. Let's take 24 times this one. Well, 24 divided by 8 is 3. And then just take 3 times 3, so that's minus 9. 3 times 3. 24 divided by 3 is 8. 8 times 2, 16. On this side, I've got 24 times 1/3. Well, that's just 8. 24 divided by 3 is 8. 8 times 1 is 8. Well, so see, now you see what I've done. I've cleared out all those denominators, making this a much easier thing to deal with. If you want to practice dealing with fractions, that's fine. That's always good. But sometimes it's just easier just to clear out those denominators, make things easier. Because now this is 16 minus 9, which is 7 on this side. So it's 54x plus 7 equals 8. I subtract 7 from both sides, and I have 54x equals 1. Divide both sides by 54, multiply by 1/54. And there it is. X is equal to 1 over 54. And that's our answer on that one. If I skip too many steps up here, let me know. I can be more verbose there. That's all for now. Thanks for watching.